So for this example, the first thing that we want to do is calculate the period. So in this case, there's a formula for period, and you do 360 degrees divided by k. Now your k value is in your equation, and it's the one sitting between the sine and the x. So in this case, k equals to 2. And so we're going to do 360 divided by 2, which is 180 degrees. A regular sine graph goes from 0 to 360. But because this one is compressed, it's going to be harder to see if you don't scale this properly. So I think what I'm going to do here is I'm going to scale it by 15 degrees. So I'm going to do 15, 30, 45, 60, and then it'll be 75, then 90. So my 90 degrees is going to be right here. Just going to take away that coordinate. So every 1, 2, 3, 4, 5, every sixth line is going to be 90 degrees. So right here. Right here. I might come off the graph a little bit. My sixth, it's not too bad. I would just have to extend my arrow. Okay, so the reason I'm doing this is because I want to be able to see what's going on with this graph, because I know that this graph is going to start at 0, just like a regular sine graph. So I'm going to start at 0, and I'm going to end at 180, 0. Okay, so this is my x values, these are my y values. So there's a coordinate of 180 degrees, 0, there's 0, 0, and then there's 360 degrees, 0. Okay. If you're doing a regular sine graph, it'll be 0 at 0, 0, 180, 0, and 360, 0. But in this case, we're chopping it in half. So we're going to start the graph at 0, and we're going to end the graph at 0. Now, in the center, a sine graph is also at 0. So this is what it's starting to look like. Now, in the middle of 0 and 90, for the first half, it's going to go up to 1. So I'm just going to put the 1 right here. Okay, I'm just going to scale this by 0.5s. So in the middle of 0 and 90 is 45, which I know is right here. And I'm going to go up to 1, because the sine graph goes up, comes back down, and it goes down to -1, but that will be in the second half between 90 and 180. So right here, I'm going to scale this by 0.5s as well. I'm going to go down to -1 and then back up. That's one cycle. You could keep going if you want, but the domain here, one cycle is only 180. So I can leave it just like that. If you want to put your sine original graph on there, you could, since we have from 0 to 360, and maybe I'll do that as well, it might help. So regular sine graph starts at 0, 0, like I said earlier, ends at 360, 0. In the center, at 180, will be 0. In the first half of that, in the middle of 0 and 180, we're going to go up to 1, so that's at 90 degrees, we're going to go up to 1. In the second half, between 180 and 360, so at that 270 mark, we're going to go down to -1. So there's one full cycle here of a regular cosine graph. So my cosine graph is in pink. The graph that's in blue is the graph with just the period. So cos of 2x. I don't know why I'm writing cosine. It really should be sine. And I know it's sine because it tells me up here in the original equation. Okay, so make sure that you write down the proper function, either sine or cos. So I've got both graphs here with just the period, but I'm missing the other transformation that's happening here. And the other transformation happening here would be this a value of 3. So because a equals 3, that'll be the second thing that we do. A means the amplitude. Okay, amplitude basically stretches your graph vertically. So instead of going to 1, we're going to go up to 3. So if I'm scaling this by 0.5, the graph up to 3 goes up to right over here, and -1 will be stretched to -3. So right down here. And I should write the scaling in. So here's positive 2, here's positive 3, here's negative 2, and here's negative 3. The other coordinates do not change. Okay, so we're going to still keep 0, 0, still going to keep 180, 0, and still going to keep 360 and 0. The only thing that changes is that this graph is being stretched vertically. So that graph in purple is the graph of y equals sine, oops, I forgot the 3 in front, 3 sine of 2x. So basically what you need to do is make sure that you set your period first and that you scale it so that your graph is visible. If you can't put a full cycle of the original sine graph or original cosine graph, you don't have to do that, but you should put a portion of it anyway. So you really need to know how your sine graphs and how your cosine graphs act. So as I said before, it starts at 0, ends at 0, in the middle it's 0, goes up to 1, and down to negative 1. So copy this down, and if you have any questions, we'll review it tomorrow in class.